Hey everybody, welcome back to Brain Sessions. This is episode 2. Um, Last time we got the template set up, got the project set up, working on a to-do list application in Green, and there's a couple things that Codex did that I want to correct just so that this project looks the way that I want it to look. Um, And so I'm going to do that. One of those things is this command events helper function that it's done, and then this to do event helper function. I don't think those are necessary, so I'm going to find those. Yeah, I don't think it's necessary. I'd rather see the whole structure of the contract between the command processor and the to do the event store in every command body. I don't need it to be extracted like this. So I'm actually gonna resume the session from. No, I'm not gonna resume the session. We'll start a new session and then maybe resume that one later. Actually, I am gonna resume it. Let's see. Okay, before we continue, command events and do necessary. The data contract. Let's see. Just do it the standard green way in every command handler. And what I'm referring to there is that every, let me make a new file. Let's choose the language. Every command handler has a contract with the command processor. And I'll explain the command processor in a bit. But a command handler is just a function, but it's a function that is expected to, at a minimum, return a map. Be an empty map. That's fine. One sec, my cat wants to get in here. Okay. It can be an empty map. That's totally fine. But it has to be something. Now, additionally, if you do some operation, so stop it, crazy cat. If you do, all right, you gotta go. Causing troubles. Causing trouble. Stop causing trouble. All right. So, the whole purpose of a command handler is to validate some business invariants. The command processor actually does automatic schema checking, so it's integrated with def schemas, which is Crane's mechanism for registering schemas in a centralized registry. So command processor does schema validation for you on commands. It's really nice. And then in command handlers, the purpose is to do business logic, figure out what's going to happen, maybe use some read models to do that. Sometimes you got to do side effects that then you can introduce into the system as events when they've been done. And then when you have events that you want to store, so the aftermath of command tooling is that you produce events, because commands are the primary way to change the state of the system in an event source system, in a grain system. And so there's a key, command result slash events. And then you can supply a vector of as many events as you would like. And an event has an ID, which is actually a v7 UUID. An event has a timestamp. An event has I think it has a type, which would be like, in our case, like to slash project created or something like that. And an event has tags, which we talked about a little bit yesterday, which is, so if this is about a project, it'll probably have the, project ID, which will be a UUID. And then the namespace part of the event is the actual event body. So if the project's name was test, that's what it would look like. And what Codex had done is it had like created a helper function to kind of paper over this declarative return structure. And I think that's just not necessary. So Grain does help with, let's see what it's done. I'll come back to that topic. Yes, so now every command handler is doing what I prefer, which is just using the contract precisely. And arrow event, which I'll just call make event, is an actual Grain helper function that that we could go and take a look at even. So we jump here, we're jumping into the event store v3 interface, and the core implementation is just a helper function to do what I just showed, which is helps you produce a valid event with type, body, and tags, and then the body just gets merged in and is the unnamespaced. Not unnamespaced, you can have namespaced keys in your event body. It's just where'd my file go? It's just that it can't be event slash is a grain thing. So for grain events, so I could have to do slash to do dot project. Like depending on how big of a namespace keyword head you are, then you can do that kind of thing. And so what this would look like now in that new structure is it's actually using the we have type tags what's the other one? Type tags body name test, and then that way you don't have to create the ID because you would otherwise always have to remember to create version 7 UUID for the event ID, and you don't have to create the timestamp, so you can just kind of send it in like this. Although I think let's see, I think it's still doing a little too much here with the task tags. Let me decide if I care about that or not. I think I do. It's necessary. So tags is a set. Let's see. Tags is, yes, tags is, it needs to be a set of these vectors. So it would actually look something like this. So you can have an arbitrary number of tags that are like a pair like this. Okay. The other place where this contract comes into play is in our case with Datastar, or okay, let's just cover with, so let's pretend that we're using the command request handler. So I can have command slash result, and return any arbitrary Eden data. And what that's going to do is the adapter, which in this case would be the command request handler, this result can be any data, and it will get translated back into an HTTP consumable format. So like as long as a command handler can also return an anomaly, like a cognitect anomaly, and that will get treated by whatever adapter you're using. So if it's the command or query request handler, that will turn like a not found category anomaly into a 404 or something like that. If you don't return an anomaly, it's just going to do a 200 or like a 2x return code, and it will include, I think by default, the command request and query request handler do transit JSON. So it'll convert whatever Eden data you supply into transit data that the client can use. On the query request handler, you can do the same thing in a query result. Queries don't produce events though. And so, but for DataStar adapter, you can supply some hiccup. So your this would be a place where you could do all of your work in your query handler that theoretically could serve different kinds of clients, whether it's just data driven, DataStar, or like TUI or whatever. And then just have a function here that for the hiccup that renders the hiccup, and then that's how you do the DataStar part. And there's some other stuff with like signals and things too, but there's a contract going on. I don't think obfuscating the contract just for like to save some characters is going to make sense. So I also want to get rid of these. Also get rid of the star tags functions. These are unnecessary optimizations. One of the great things about commands and queries and everything being declarative is that we'd rather be able to come in here and look and see exactly what's happening rather than like kind of obfuscating what's happening just to like try to save some characters, because it's all data at the end of the day. And the one thing that really does make sense not to repeat everywhere is what's necessary for building an event. I'd rather use the grain helper function for that. That's what it's for. Let me reload this file because it's probably outdated now. Yeah, okay, so this is better. So now if we just look at move task to bucket, we can see that the command coming in on the context has task ID, bucket, and order within that bucket. We run a helper function called require task, which is probably going to validate that the task exists, and it's using the tasks read model for that. Then we're going to check if there is basically if this task is an anomaly, and if it's an anomaly, then we are returning a conflict. Otherwise, we do the thing, and the thing in this case is figure out the order, and then we produce the grain command processor contract, which is that we have some events, and it's one event actually, and it's typed to do task move to bucket. It's tagged by task, and the body is a task ID, a bucket, and the order. And when a grain command doesn't return any client result, then it just sends a 200 and OK in the body. So, which is fine for a lot of cases, especially like with this DataStar setup, because I don't actually want to be returning a lot of data with my commands. I want things to just change on the server side and update automatically in the client's view. So it looks like we got rid of all those. That's all fine. Let's see if it's doing any stupid stuff. Queries. I don't think it is. Not that I see. That looks like that was about it. I do want to take a look at whatever that required task was, just to see what's kind of cooking up on these. So let's see, required task takes a system context and a task ID. It gets from all tasks the item with that task ID. Otherwise, it returns a not found anomaly. So I'm actually fine with that. And all tasks does what? All tasks is a wrapper around read model processor project, which takes a system context and then projects the to-do slash tasks read model. In the to-do slash tasks read model, we can find up here, that would be this one. It takes obviously the task event types, so all of the relevant event types for manipulating tasks. And then it has this multi-method that acts as the cases for the reducing function. So like when we first capture a task, we receive an event with these keys. We optionally, so we have kind of a base map that we're going to create there in the state. And then we optionally add a couple of other items depending on if they exist or not. Let's see. I'm gonna commit that work. What else to explain right now? I think it could be worth going into. So Brain has a few fundamental primitives. We've got commands, we've got queries, we've got read models, we've got periodic tasks, we've got to-do processors, not to be confused with our to-do list application. We've got events, we've got schemas. So if something doesn't fit within one of these categories, it's wrong. And there's only 1, 2, 3, 4, 5, 6, 7 categories. That is how we can constrain AI code automation. I'm getting the impression that people are going to start trying to solve this architecture quality and drift problem at the harness level. And I think what actually makes more sense is to have harnesses that are very capable and solid programmers, if you will, and then combine them with sort of a decoupled substrate, which in the past we would have just called an application framework, but application frameworks tend to be too general purpose. You can still make so many decisions that you shoot yourself in the foot. And that is why so many decisions that there's no uniformity, right? And that's why like teams of talented, smart people use popular frameworks to this day and before AI that they produce unreasonable systems because there's so many different ways to do something, and the industry is just very prone to really bad habits when building information systems that I'm not really going to get into today, but it's just the truth. And there's already been a better way to build information systems for a while now. It just hasn't fully caught on. And that's essentially event sourcing. And so Grain is an opinionated way to do event sourcing. And it just so happens that it also serves as a great substrate for constraining how code automation works. And so commands are the primary method of changing the state of the system. It's a request, it's packaged intent to change the state of the system. Um, Rather than having a million post endpoints in a REST API or something, you have a single command endpoint, and there you have a command registry behind the scenes on the server, and the client sends a named piece of little package of data that has all the parameters required and arguments and the right metadata. And it specifically says, I'm going to do something. I'm going to capture a task. I'm going to mark a task as archived. And the commands are handled by the command processor, which is the, sorry if I misspelled some things. I don't think the spell check is really a thing in this text file. Which is the canonical method of handling a command. So the command processor does things like logging, schema validation. Let's see what else. Event store append, writes to the event store. It really doesn't do that many things. It just does the things that all commands need to have happen for them, so that the builder, the user of the system of Grain, the developer doesn't have to do all of these things each time. It's not like rocket science. It's just a place. It's just a component of a system that does one job and does it well. So queries are the primary method of reading the state of the system. There's also a query processor. It handles logging, schema validation, and that's kind of it for the queries, for the query processor. Now, keep in mind that, well, no, that would only really apply to the adapter layer, so never mind. Read models. Read models are the primary method of projecting current state from event store. So one thing that really trips people up when they are new to event sourcing is the idea that there's no like relational database schema with all these entities and things like that, that is foundational to your system. And what I mean by foundational is it's not that you can't have an event sourced system where your read path is a relational database schema. You can totally do that. You can project all of your entities out from the event store into a Postgres schema or something that looks just like a schema that you would use to build your application in like a more conventional way. But in this case, it's not fundamental. And what I mean by that is if you record all of the facts of everything that's ever happened in your system and it never forgets anything, then you can project out probably an infinite variety of relational database schemas if you want to. You can project out to any kind of what's the current state of my application paradigm that you like. But you can't do the reverse. If you have a mutable point in time database, like you just build a system like most people do with you design your entity relational schema and you do all of your operations in a way that mutates the current record or row for a particular entity. You cannot project out all of the things that have ever happened unless you went through great pains to design your system to support that, in which case it's probably really complex to look at if you did that, because it's really just not a paradigm that melds well. Whereas if you're doing event sourcing, you could you can project out into a variety of different ways that actually serves your application in different ways when needed. And so having facts be fundamental is awesome, but now you have to think about things in a different way. You have to say, oh, okay, what I care about is the fact that things can happen in this universe, and then it's up to me to decide what perspective different parts of the system have on the things that have happened in that universe. And that's where read models, or you could also call them projections, come into play. And so a read model in this case would be like our tasks read model that we were just talking about. It's nothing fancy. It literally just means given all the events for a particular for the system that are task related. So these are the task related events. What's the current state of things? And the current state of things is going to look very familiar to you. It's going to look like maps or objects with keys that are, should be on task items and things like that. And may even remind you of like a database table. You could you could put the end result of a read model in a database table with columns and things like that if you wanted to. It's just that it's not fundamental. So it's up to you as the developer to decide what is my what's the perspective that the system needs to have over these events. And so we also have a read model processor in Grain, which is a bit of a newer addition, but it handles things, very important things like the main thing it handles is incremental snapshotting and caching. Now these are pluggable behaviors if I do recall, but essentially one of the chief initial. Okay. So if parentheses are the thing that people over-index on when they're not used to Clojure and Lisp, then latency of read models is the thing that people over-index on when you talk to them about event sourcing and they're not familiar with it. They're going to say, whoa, you got to rebuild the current state of your system every time from events all the way from scratch. That's going to create a lot of latency. That's actually true. I mean, that is true. So it's just a problem that needs to be solved. And you actually don't even have to solve that problem if you don't have a substantial amount of events. Just the use of proper tagging with Grain's event store, unless you're building like an admin dashboard or something that has to have a cross-cutting view over like all of the users in a system or something like that, most entities have very short chains of events in isolation. And so tagging is also it's indexed in the Grain. Tags are indexed in the event store in the Postgres backend anyway. And so it's really not a problem a lot of the times. You just have to monitor your latency. But in the case where you do have more kind of hefty requirements and you want to maintain like a latency target for the users of your application, like say, I want all of my interactions to be sub 150 milliseconds, then you have to think about this incremental caching and snapshotting thing. And so that's what the read model processor does. I'm not going to explain exactly how it works today, but essentially because Grain is an event store, an event sourced application, and also because Grain's event IDs are version 7 UUIDs that have time baked in, and the way that events come in and are appended is sort of in a total ordering of all identities occur in the order that they happened in. And because the database is immutable in that sense, we can basically do what's called watermarking, and I can project the tasks read model here, and the next time I go to project it, I just have to check what's the last event that I've included in this read model, and has anything relevant happened after? Give me all events that have happened after the latest event. That's a pretty quick operation, and then you just fold those new events in, saving the reduction time that you had spent on the first sort of instance of projecting, and then cache it on disk, in this case with LMDB. I believe the cache infrastructure is pluggable, so it's probably possible. Grain has this KV store protocol, and one implementation right now is LMDB, but I think it'd be possible to put like Redis in or whatever. So the read model processor handles incremental snapshotting and caching. So anyone who buys into Def Read Model gets this stuff for free. So you don't have to think about it as a user of Grain unless you want to. Periodic tasks, primary method of doing things periodically. Imagine that. There's a periodic task. It's just called periodic task. It's not called a periodic task processor. Periodic task. So these are interesting, actually. Um, I made some changes to Grain to support a project that we were doing. And it gets into a little bit of an advanced topic with the control plane that I don't want to go into today. But essentially, a periodic task will periodically, like on a cron schedule or otherwise, emit events. So they used to be in Grain Core version 1, periodic tasks were, they had like an arbitrary function and you could do whatever you wanted, but now they can emit an event. So if you have an event that is supposed to trigger a job, like an asynchronous job, you're typically going to need to pair it with a to-do processor. So suffice to say that periodic tasks can periodically emit events. So then we have to-do processors, the primary method of reacting and doing things async in Grain. Doing things async. So I think this one also just has the machinery is called to-do processor. This handles like logging. There's some it handles some kind of side effecty thing. I'd have to look into it again, but you can do you can basically do effects. You can I think you can directly store appends events. It has a similar contract as the command handler, and subscribe to topics, which are just event names, in order to do things. And these also it also handles checkpointing. And some semantics where you want to checkpoint before or checkpoint after, because you've got to think about systems that are in the middle of deploying, crashing, whatever. When you go to do an asynchronous background task, of course the developer is also always required to think about idempotency. You have to program that in yourself to your to-do processor handler, but you can also tell Grain, hey, do the checkpoint before or after, and that's gonna determine like if the system comes back up for that particular to-do processor for that particular tenant, whether it actually runs the to-do processor again or not. If you checkpoint before, you're saying, hey, before I do my action, go ahead and say that this is done. So I know that I could fail afterwards, and that's really on some downstream process to figure out. Or you can say checkpoint after. So I'm going to do my effect. I'd rather do my effect again if we come back up and this to-do processor hadn't finished checkpointing. So just try it again, and then checkpoint. So it handles like basically catch up and replay and all of that stuff for you. Events are the source of truth. In a Grain app. Events are the simplest way that we can represent data in an information system. It's the things that have happened, and it's up to us as the creators of the system to form a perspective about it and make that perspective usable in decision making when reading and writing against our application. Schemas are the glue. We have command schemas, event schemas, query schemas, read model schemas, and all of these are centrally integrated by the def scheme. So let me actually put up so for commands, we have def command. queries, we have def query. For read models, we have def read model. For periodic tasks, we have def periodic. For to-do processors, we have def processor. There's no def event. An event is just the artifact of everything that's happening. So the closest thing we have is just the helper constructor for creating an event. And then for schema, we have def schema. Def schemas. Def schemas, so all of these macros form the primitive language that either a human developer or AI has to use to build a system in Grain. And no matter where you look, no matter when you look, the system is always going to be composed uniformly out of these primitives. And these primitives allow. So when you use these things, there are runtime registries that commands, read models, all the primitives get registered in. Same with schemas, and schemas become a way for Grain to help the developer enforce data shape validation all throughout the application, especially at the edges for commands and queries, and then helps prevent storing events that are invalid. So that's kind of the rundown on what I mean by shallow substrate when I talk about it. Is that sure, like a coding agent could try to choose to do something other than a command, query, read model, periodic task, to do processor, or write a schema. But how easy would that be to see, to notice? It would be so easy to notice, like, hey, somehow you got off the rails because you're doing something novel when this system has no room for novelty. The novelty is in how we combine these components together, not the components themselves that make up the uniform architecture of the system. And so, but additionally, it's unlikely that the AI is going to stray because Grain projects and Grain itself is so self-describing and declarative that the project over time becomes the ambient context for the code automation to be kept sort of always regressing back to the right, to stay on the train track, to stay on the rails. It can see how everything is done, and it's done in these primitives, and so it becomes obvious. And that's why, like in the last session and in this session, I don't have to baby it. If it reads the Grain source, if it reads now reads the project, then it's going to be on the straight and narrow. And one of the reasons that I had it take out those functions a minute ago, those helper functions it wrote, is because the patterns still matter. So you want to set good precedent for your code automation. But knowing that it can't stray off these rails without you noticing it is a true. It's a win. It's a huge win. Okay. Let's see. What should we do next? Let's see. All right. Let's see. I think we cleaned up the stuff pretty good. Okay, I think so. To move forward, to move beyond just this one large file, because we've got a to-do list application with about 1,000 lines here, which is pretty sweet. I mean, Clojure already produces systems with a minimal amount of lines of code, but Grain systems tend to be pretty compact. However, I want to break this out now because I want to. Actually, I don't want to break this out now. No, let's actually just keep going with the plan. So I'm gonna fire up the InRepl server again and the CSS runner. And let's see. Okay, so where are we with the plan? Hopefully it still has the plan loaded up because I resumed the session. Yep, we got to finish project workflow polish, task workflow verification. Okay, let's keep going. Hopefully that was a pretty good explanation of Grain's primitives. It's actually, it actually reminds me a lot of Clojure. It's like there's so many cool dimensions to the experience of using it that it's really difficult to talk about any one of them, because what happens is you've got so many like magic beans that come together that you end up with a system that is more more enchanting, like all together, than the sum of its parts. And so you really have to have the experience of what it does for you to get it. That's why it's hard to convince people to just like convert to Clojure or something, because you can't just like try to make some kind of objective case to them. A lot of the stuff is rooted in preference, which makes people uncomfortable. But you have to bring someone to the point of having that kind of magic experience. And for me, the magic experience is being able to make money um, with these tools and be able to produce software that I would have produced anyway. I'm a grain programmer, so I would have been using this anyway by hand. So nothing's changed about my workflow except that I can hit the accelerator. And I think that that's like, it's a really beautiful thing. All right, so it looks like we're producing some tests over here. I'm actually going to pull up the application. I don't know if it's running yet. We have here local host 8080. It's not running. Okay, I'm just gonna. Well, we'll hang out and see what it's doing. Let it cook. And okay, so while we're looking, earlier, so we saw, like in the session yesterday, we saw that our like kind of mock homepage had an empty read models map, but in a query that properly sets up and declares its read models, you can see we have three read models here: tasks, projects, and weekly review. And then the one is the version. So we're using version one of all of those. And that's what it looks like. And so the chain, when the data star adapter is looking for relevant changes to a particular query that it's running, or that it's subscribed, that a user is subscribed to, it knows, because there's a grain. Remember, there's a registry for all of the read models, queries, commands, everything. So there's metadata that can be looked at to say, to do tasks version one. Well, what are the events, or what's that read model look like? And as we've already seen, it looks like this, and then it says, oh, what events does it care about? And we know what events it cares about, because you have to supply them to even build the read model in the first place. And so if any of these things happen, if any of those come through, and then you can multiply that actually by if any of the events relevant to any of the tasks read model, projects read model, or the weekly review read model, because we're on a review page, then the UI is going to automatically, or the data star adapter automatically reprojects. Yes, we can connect. It automatically reprojects the query that's being subscribed to, which is this query, which in what I like to do is, you don't have to do this, but I think it's actually better, fat queries, which means essentially mostly a 1-to-1 ratio of query to screen. So most queries are just going to be screens, and so it's going to be a screen that composes together multiple larger read models and then can serve the data in UI as needed. So that screen query is going to re-render when something changes with any of those read models and automatically update on the front end, which is really sweet. It's really sweet because it allows you to move state and complexity of the application to the back end, which is what this kind of like new push for minimalism on the front end is. And it means that your front end application can be very, very thin, because all it's really doing is streaming updates to the client. Like Datastar is a small zero dependency library, and it's awesome for that. All right, so we got bringing on Playwright, and we'll allow it to do things. Now it may be broken, so we gotta let it figure that out. That's the thing. When things are broken, I'm just like, I'm not gonna figure that out. You go figure that out. It's your job. AI, Codex, Claude, whoever. All right. Well, to prevent it from wasting too much time, I'll just let it know. Screen is blank. Thing is wrong. Figure it out. I don't even know if it started the app. I mean, I presume it did. Let's see. Yeah, it started the app. So something's just up. We'll have it figured out. Okay, it's finding a route collision. In fact, I see. Okay, so I see it's trying to do. I mean, you should be able to do this, and maybe there's a bug in the Datastar adapter, but should be a request. Moving project detail to / project ID. Okay, I would actually prefer query query args over route args. So we'll see. Maybe it'll even decide to update project memory. I really don't care. Like, I tend to be a minimalist on this agent stuff. Like, I don't want to build a house of cards that I have to remember to bring around with me everywhere. I want my workflow to actually just work given the project structure. So I don't like fiddling around with like agent memory and all that stuff too much. But sometimes it makes sense. Sometimes it makes sense to tell it to store some details. So we'll say make a note of that too. Do, 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 do. All right, come on, come on. A lot of spare time to think in this day and age. Yeah, but I think after we get whatever the initial plan is finished, we're gonna split commands, queries. We're gonna split all the primitives into files named such, like commands, queries, read models, to do processors, all that stuff. So we're going to move out of this one file pattern and we'll add some extra files here, which actually will illustrate like what I consider to be a grain service component. Although we're no components in this project because it's not a polylith project, but a grain service tends to have a very specific shape. So in a production context, in like a polylith structured application, there will be components with a name dash service, and those tend to be nicely wrapped up packages of commands, queries, all the primitives, and if you were to visualize them, it would look like an event model, as opposed to like foundation components, which aren't information systems. They're like pure components and things like API adapters and stuff. Okay, so we've got our situation loading up here. Okay, let's keep going then. So we got our project ID in the query args there now. We're going to have to do a UI path at some point. I actually have a subscription to this guy. These are the people that make Tailwind, I think, and they also they wrote this book called Refactoring UI, and you know they claim that with this MCP server, you can get all of the best thoughts and ideas that they've compiled into this book and stuff, and inject that into your agent for doing good design work and stuff, or like building more compelling designs. Looks like it's doing some. Looks like it's doing some UI cleanup for the Do Soon UI, which I don't think I've even seen that yet. Here, let's go over on our side. Localhost 8080. So we've got plenty of UI stuff to clean up. I'm gonna stop repeating that over and over again. Now let's see. Project query arg smoke test. That's the name of the project. Projects can be completed. I guess something that's interesting is like why aren't like if there's the option to put things in the different boxes, like here, where are those boxes in the project view? Updating tests. Sitting around waiting for AI. All right. Yeah, one of the challenges has really been, well, it's not even a challenge. Like we've just been heads down, you know, working and using this stuff in our work. And I want people to know about it. Not not telling people they need to use Grain. I mean, you totally can. It's open source. It's MIT licensed, but it's the ideas that are powerful. And if you understand those ideas by me explaining them, then you can actually go build your own Grain if you want and use it to make money with. You can get ahead of the rest of the industry right now, which is struggling to understand how do I use AI code automation in a way that I can actually be responsible for the output. People are grappling with this because they've been using paradigms that are not actually good for building information systems for 2 decades now. If all of the decision making is aligned in the right way, then it becomes a non-issue, and that's what Grain cobbles together all of the decision making um, ideas from various places and puts them together. And the sum of its parts means that you just have a paved road you can drive down, whether you have a team of humans or a team of humans with AI. I still think human in the loop is very important. Like I don't push out work that I don't make plans for in plan mode and read the plan and adjust the plan and things like that, and sit there and I'll catch red flags while the plan's being implemented. And like human is still very very necessary for building good products and stuff with AI. But what we want, like what AI represents to me in coding, is labor automation. I can now do so much more because I can automate the labor that I have to do. And so being able to control that and not have it be a mess is what Grain allows you to do. The Grain approach. And ultimately that's a product of understanding simplicity, as in like simple made easy by Rich Hickey. Um, and some of the other ideas, like basically any ideas that Rich has shared over the years in those talks have probably gone into this. Okay, so we're looking at our weekly review here. I wonder what's troubleshooting. Last time I looked at this, it wasn't quite working all the way. I guess we can go check it out on our side too. Yeah, it doesn't do anything yet. Yeah, review page works, but gives no feedback after marking items reviewed. Review changes are in place. Process a level test. Interesting. Curious what that is supposed to do. Maybe if I knew more about getting things done, the GTD methodology, I would know what that does. Okay, so I'm curious what this even is supposed to do. What is weekly review supposed to be for? Is that a GTD thing? Yes, weekly review is a core GTD practice. Its job is to keep the system trustworthy. In GTD, you capture tasks and projects during the week, then periodically review the whole system so stale tasks, unclear projects, waiting time, and some someday items do not rot unnoticed. In this app, weekly review is meant to guide the user through reviewing each bucket. So it's not a separate to-do feature as much as a maintenance workflow. Our implementation is intentionally basic. It tracks the reviewed buckets and projects and only allows completion after all are marked reviewed. Um, yeah, it doesn't appear very useful right now because it doesn't show anything other than what needs to be reviewed. It doesn't actually surface items to look at. Is that the intention? If I was working on something for like a client or my own thing that I actually care about, I would have my own intention, but we're letting this thing cook a little bit, so no, that shouldn't be the final intention. What we have right now is mostly a checkpoint mechanism. Mark these areas as reviewed. It proves the projection loop and the event processing, the event sourcing part. For a useful review, the page should surface actual material to inspect: inbox items, next waiting someday bucket contents. The mark reviewed button should probably sit next to or below those lists, not replace them, so the flow becomes inspect the actual items, clean them up if needed. The next good implementation step is to turn /review from a checklist into a review dashboard. Okay, let's add that to the plan. So we're back in plan mode, and we're just going to add this back to the plan so that we don't have this useless review page. Okay. Turn weekly review from a checklist into a useful surface. Page should show. Yeah. Yep. Keep current review commands and events. That's all relevant. Add review specific query data from existing read models. That's just how it works. Update the UI. Keep completion disabled. Show empty states. Use existing grain projections only unless you need to make a new one. Yep, all of that is good. Maybe let's see. So given this plan, what's the user's workflow experience like? Maybe we can do a little shaping up here. So the intended user workflow would be they use the app normally during the week, capture inbox tasks, move clarified tasks into next waiting Sunday, assign tasks to projects, set due defer dates, and they complete and cancel things. When they open weekly review, they're not just shown a checklist, they see the actual work to inspect. Inbox tasks to clarify, next tasks to confirm are still next actions, waiting tasks to follow up on, someday tasks to reconsider, due deferred tasks, and active projects. They review one area at a time. For example, in inbox, they look at each captured item and can rename, move, assign to a project, defer, set, due, complete, or cancel. Once that section looks right, they mark inbox review. They review projects. Each active project appears with counts and relevant tasks. Projects with no active actions are called out because that's a GTD smell. The project exists, but there's no obvious next step. They review time-sensitive work. Due soon, overdue, and deferred tasks are surfaced so dates do not silently become stale. They finish only when the system is trustworthy. The complete review button stays disabled until all buckets have been reviewed. So the experience should feel like, walk me through everything I need to trust my system again, not click these abstract review buttons. That does sound pretty good. And I guess I have one concern. So are we in a position to avoid duplicating UI components? Do we have a component gallery in order to start creating a substrate for composing screens in this app? And if not, then I'm going to add that to the plan because I don't want it to. It's clearly going to have to put a lot of things on here that appear elsewhere. So we do have some reusable pieces, but before expanding, small substrate for, yeah, I would not create a big gallery unless we plan to iterate heavily on visual design, lightweight components. So soon we will iterate on visual design, but for now we're just preparing ourselves for that. Okay, let's go. All right, so we'll let it build out this weekly review experience a bit more. Who knows? Maybe we'll actually end up with a usable personal AI powered GTD to do list app or something. Seems like that could happen. Now we let it cook. I probably should have had it commit earlier, but it's fine. It'll be fine. Yeah, if this actually does become useful, a local application is just a matter of using the SQLite backend. And maybe we can even build a terminal user interface. I haven't actually merged in the adapter for that yet, but there is a branch out there for Grain for building like Grain native GUIs. And we could even do a desktop app in Clojure Dart, maybe. Oh man, this thing must be cooking. Taking its sweet time. I may end up live streaming at some point. I'm kind of just like practicing that right now by doing these uncut videos because I want people to see like what the workflow is actually like. Even if someone like hates Grain and never going to use it, I don't care if people use it. But I do think that there's so much confusion right now about how to actually do good work with these code automation tools that just seeing the workflow in its true form, and everyone has a different workflow, so mine's going to be different than someone else's. I tend to be like a bit of a minimalist, so I try to make sure that my workflow works. Like I should be able to swap in Codex or Claude Code or whatever and hit the ground running. I don't carry around like a bunch of agent markdown files and things like that. I let my Grain project serve as the context because Grain is kind of like a pressure cooker. It's like an ecosystem. The more I stay within it, the more powerful I become. So what is this? What is this fool doing? 3 minutes. Sure, it's doing something useful. What if it's just like waiting for? It's like waiting in line at the token buffet, the lunch line for processing tokens in the OpenAI data center. It's probably thinking, but this one doesn't actually tell you when it's thinking. Doesn't even seem to tell you when it's using tokens. Claude Code does. It does tell you when it's doing that stuff, at least for now. There we go. Starting to kick things off. Yeah, it's definitely a good idea to. The cool thing about AI era, AI code automation, that is that like incremental, like those sweeping incremental refactorings that take a long time but do add up when you do them all, um, that you would normally put off, right? Like, especially in a work context, you'd be like, oh, we don't have time to refactor. We got to just keep moving. Those things become really cheap. So it's like you can let things kind of develop organically, and then you can rein them in. Kind of like we got our first sort of like UI primitives in, and now we can rein it in and turn that into a more of a component system. That way, when we go to actually do the real UI pass later, um, we don't have a bunch of bespoke stuff to deal with. We can deal with a component gallery. Like, it's those kind of things that I found like to be pretty liberating, as because I think as developers we often like look at the sort of mess we've created, and we can see the potential, but it's like, oh, it would take me a week to um, refactor XYZ. Well, now it's like you could do the week of refactoring in a day probably. And I find that to be very like one of the nice fun parts about this. I find most of this to be fun actually. And we got to get while the getting's good, because there's an arbitrage window on this stuff. Token usage is probably going to get more expensive in the long run. Um, Also, right now the market is so fragmented on how it thinks about AI, like developer market, companies, everything. It pays to get ahead right now. Like if you can get ahead and actually have a solution to a problem people are grappling with, it's not that you need to sell the solution to those people. It's that you can do more work faster than them for now. And that window is going to close as the world kind of adapts to this technology. But for now, that window is open. It's pretty sweet. Okay, let's proceed. Okay, so now we're going to build out the actual function of the weekly review. Another reason I'm not like editing these really is, I mean, whoever's watching can just watch it on like 2 times speed, and that way I don't have to cut anything out that someone might have been interested in. And it gives me the time to think if I want to explain like grain concepts, which I feel like I did a pretty good overview earlier. The only thing might be maybe next time I can draw a picture or something that really shows like how the architecture gets laid out. I'm excited to see what comes of this, and I'm excited once we get to the end of like the basic implementation to pull in orc, which is our behavior tree based. Just meant to go to GitHub, which is our behavior tree based agent orchestration framework that is fully integrated with Grain. Um, it can do so much. It can do so much. It can do JEPA, which means you can set up workflows that are able to evaluate themselves and improve over time. Um, it has these ontology capabilities that are kind of like RDF esque. So agents themselves can use the ontology framework to get better at the job they do because they learn about the errors and successes that they experience and build an ontology out of that that becomes relevant in future iterations. Um, I think we have some general purpose stuff somewhere for actually just building ontologies in general, but we also have this we have something that can basically inspect an MCP server and build a workflow, build dynamic workflows that actually can utilize those tools. We have Langfuse integration for tracing. Orc actually captures all of its own traces on a node by node execution level, so that you always have the traces internally, because we use those traces to do evaluations in the JEPA tuning. But you can also kind of, as a side effect, push those to something like Langfuse, and I think that can be made pluggable, but you don't have to have it. And then we also have some really cool stuff around RLM, which is recursive language model, which is becoming, which is gaining steam. It's basically the idea that if you have a REPL enabled um, kind of harness, agent harness, it can actually do things that would ordinarily fill up a context. It's like it allows it to explore a domain and problem space in a data space symbolically, and so you can have very very large like documents, images, artifacts, whatever data sets, and have an agent that can actually use a REPL to explore those things, therefore never putting the entire like data context of its job in memory. It's actually a very like interesting thing that's come out. There's some papers on it, and Orc can do that. So Orc actually takes it up a notch, and basically we decided to pursue this angle where like an RLM behavior tree that knows how to do RLM type stuff, actually its primitives are Orc behavior trees, and so it's behavior trees that create behavior trees, and we have some interesting benchmark stuff in the repo about that. Let's see what's going on over here. So now the review looks like, which is interesting. I'm not going to over-index on the actual layout of things yet. So there's nothing in the inbox. So if we go back to the main page here, I can open a review. I see that the review is in progress. So I can say, okay, yeah, active projects. These are, I can open it, I can look at it, I can go back, I guess. I can say, I reviewed this, um, someday reviewed, and then, yeah, so assuming I reviewed all of this stuff, I can complete the review. Nice. And I'm sure we could show a history of reviews if we wanted to. Okay, so that looks good. Okay, let's commit then. All right, I think now would be a good time actually to, after we commit, split all the primitives out into their respective files. Actually, I don't know, but this isn't hurting anyone to be in here like this, so I'm actually not going to take that step yet. I'm going to leave it. It's a lot of scrolling, but it's clear, it's very well segmented anyway, so it's fine. I mean, and how much am I scrolling through here anyway? Well, in that case, should we do a UI pass? Let's see how. I forget how to actually do. Let's see. How do I actually use this UI.sh thing? UI.sh. Ugh, I'm gonna have to look up the instructions for that. One sec. Ba, 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 ba. Okay, I'm just gonna do this here. Okay, and then I think I will just resume that session. Oh, what's going on with that? Where did my VS Code go? Oh, there it is. That is not working exactly right. Oh, I see. That's annoying. Ugh. Okay. Well, maybe I'll do this another time. All right then. Okay. So it looks like it's been about hour 20. So I think I'm gonna wrap it up here. I think the next thing that we can do in the next session is do like a UI pass and really come up with an aesthetic and design that we like for the experience. Because this is just like this is what came out of the model by default. So we're gonna take a crack at it. The I was gonna do that today with UI.sh, but I need to go and do some setup with that, and it's super annoying because it puts your API token in the dang instructions. So when I can't work with it, I can't set it up on stream here. So I'll just have to get that working. But okay, hopefully the explanation of grain primitives was helpful to you. The repo for the project is public, so I will put that in the description of the video. And yeah, we'll pick up in episode 3. So thanks for watching and have a good day or night or whatever, and see you soon.